Hello and welcome to another tutorial video for the Industrial Robotics Framework Machining Cells. In this video I'm going to be covering how to prepare a CAD model for loading into the cell such that it can then be trained and eventually run in production. The Industrial Robotics Framework system makes use of the third-party application called RoboDK. This application has plugins for common CAD modeling software such as Solid Edge, SolidWorks, and a number of others. In this situation, I'm going to be covering how to make use of how to prepare the model using the Solid Edge CAD modeling software. So we can see here I have Solid Edge open and a part loaded into the interface. So, the first thing that needs to happen for this part is we need to obtain an STL model of it. This can be done simply in Solid Edge by clicking Save As, changing our desired file type to STL, and we're going to go into the Options tab. What we need to make sure of here is that our output is set as binary and that where tolerance is set as custom with the conversion tolerance set to 0.005 of a millimeter and the surface plane angle set to about 30 degrees. Ensure that your export units are in millimeters. Once you have set this up, you can click OK, and you should not ever have to do that again. Now we've got to choose our location for saving. In this case, what I'm going to do is create a new folder, and this folder will be named the same as the part. So in this case, 10028, I will be removing the brackets and 1. So that will be, there we go. So I will remove that. So I make sure that the folder is the same name as the part that I'm going to save. So I'll just go into there and click Save. Solid Edge will now generate that STL. There we go. It can take some time depending on the complexity of the model. As you can see here, there are a number of splines. Now, the next step is to use the RoboDK plugin for the selected CAD software. So in this case, Solid Edge, you will find RoboDK next to the tools. If you click on that, you will be presented with this little window. What you'll want to select is Load Curves. By doing this, I am intent on using the CAD training method inside of the framework HMI, in which I select the edges within the CAD software that I want the system to train on. You do not need to use this method if you're intent on using marker training instead, but this is the standard use for CAD training. So, we will click on the Load Curves, and you can see here I can now start selecting the curves that I want to run. Ooh. In this case, a deburring operation would typically run around the outer edge of the spline. So what I will want to do is, holding down the Control key, allowing me to select individual edges, start selecting the edges around the spline. Now within the framework system, you only need to select a small portion of the edges, and this will, by default, select the entire edge around the part. So I no longer need to continue selecting. About that much should be fine. I can then go and start selecting the other edges that I would want to run. So in this case, I might want to run the inside edge as well. And for example, I might want to run this lower edge. Once you have selected the portions or all edges that you want to train the part on, we simply click Done. You'll see here the RoboDK environment opening up, and it may be a little difficult to see, but you can see here little black lines across the interface. These three line up with the lines that we selected inside of the CAM software. So what we need to do from here is you'll see the object for those lines in the design tree. We right click on that and click the Export Curves option. This will generate a CSV file for those edges, and we want to save that with our STL. So in this case, I will go to our STL and I will rename to the same as the part, but obviously with CSV. If I now enter this folder, you can see I now have a CSV of the same file name as my STL, and this is all the components that I need to start training the system using the CAD method. You will still require the STL for the marker training method, but this was what's required for the CAD training method. To now load this data onto the system, we will again be using the File Explorer, but instead we need to make sure we connect to the system through the OpenVPN. Instructions for setting up the OpenVPN will be available in the user manual. What we must do, once it's installed and set up correctly, is we will right click on the icon and connect. This will bring up our VPN connection window, and we simply have to wait for that to connect and say that we are all good. Now we can use the File Explorer and type in the IP address for the specific cell that we want to use. In this case, if I want to say connect to the deburring cell, I would use the path in this case of 10.8.0.5. This will likely require some sort of login, and then you'll be taken to this framework folder. We enter this folder, and you'll see a number of files in here, but the important area you need to be focused on is the models folder. This is where we store all types of models that get included into the system. So we will enter the models folder, and you'll see two additional folders, jig and lib. So in this case, we are loading a part that is intended to be run. Due to this, it is a library part in the case of the system. Library parts obviously then go into the lib folder. If we were to instead be loading in a jig file, which would likely just have the STL inside of the folder, then we would be going into the jig folder instead. But for this case it is a library part, so we'll enter the lib folder. Inside of this folder you'll see all the parts that have been loaded previously into the system, each with their different folders. All we have to do now is take our folder, drag it across, and copy it into here. Once that's done, the system will automatically detect that it has arrived and start processing that part and generate all the required files. And that is how you prepare a part to be used with the framework system.